A skill that you learned in grade 9 and that you will use repeatedly throughout this course is to come up with the equation of a line, or the equation of a linear function. Most often in math and in this course, we will refer to the equation of a line being in the form of y equals mx plus b. So for example, an equation might look like y equals 3x plus 4, or y equals negative 1/2 x minus 7. There are other forms that the equation could take. Something like, for example, 3x plus 4y equals 12 is also a linear equation. And what makes it a linear equation in all of these linear equations is that they have two variables in first degree. Neither of them are squared or anything like that. So they all have a y and an x, a y and an x. But what is great about the y equals mx plus b form is that it has two significant parts to it that tell us a lot about the equation. The m part, which is always the slope, and of course the b part, which is always the y-intercept. And which is why this is either called just the y equals form for short, or it's called the slope y-intercept form. Determining the equation of a line in y equals form will always involve these two things in this order. You will need a slope, and you will, once you've found the slope, you will use it to find the y-intercept. In order to come up with the equation of a line, you will always need two pieces of information. One, you will need the slope, and number two, you will need one coordinate that you know is on your line, or that the line goes through. Now, the one coordinate will pretty much always be given to you, but as far as the slope is concerned, you may be lucky and it may be given. Very often you'll have to calculate it using the slope formula m equals y2 minus y1 over x2 minus x1. That's the rise over run formula. And sometimes you may have to glean that information based on knowing that your line is parallel to another line or perpendicular to another line. Here we have an example where we have to find the equation of a line, and we're given 2 points. Now, never a bad idea to just give a quick sketch of what this looks like. It doesn't have to be too neat or too in-depth, but if I'm going to say that, I'll call this point A, maybe, and point B. Here's A, somewhere in the upper left quadrant, and B is somewhere about down here, right? And I know my line is going to go through the two of them. So this is my line that I'm finding the equation for. As we said, we need slope first. M equals y2 minus y1 over x2 minus x1. And of course, those numbers just come from my points. x1, y1, x2, y2. And so subbing in those points, so negative 6 minus 4 over 3 minus negative 3. I get negative 10 over, I'm going to be careful here, 3 plus 3 is 6, and it looks like I get a fraction. Lowest terms, I think it's going to work out to negative 5 over 3. I was expecting a negative slope just from my picture. I can see, of course, that my line is traveling kind of down as I go left to right. I mean, that means it's a negative slope. So I'm going to take my slope and I'm going to sub m equals negative 5 over 3 into y equals mx plus b, and that gives me y equals negative 5 over 3 x plus b. In order to finish off my line, I need one other point. Now, I've got 2 points here that I could use, and I'm just going to pick one, and I'm going to say that I'm going to sub in my A point, which is negative 3, 4, and here we go. So of course my coordinates here has an x value and a y value, so I'm going to sub in that y is 4, and I'm going to sub in that x is 3, like so. So 4 is going to go in for the y spot. The other two values stay in there. I'm going to sub in that x is negative 3, so that goes in the x spot. And now I have an equation that just has only the variable of b. And if I solve this equation then I should be able to solve for b. So here we go, 4 equals, well, negative 5 over 3 times negative 3. These 3's will cancel out, and I will get positive 5 plus b. And if I subtract 5 from both sides, I will get that b equals negative 1. So therefore, my equation should be y equals, I keep the m value, I keep x, and I sub in the fact that b is negative 1. And I just take a look back and I say, does this b value of negative 1 make sense with my y-intercept here? And I think, even though it's a rough sketch, I think that could make sense, that could be negative 1. Here's another example where we have to come up with the equation of a line. And as usually, we have the point that our line goes through. Right, this is the point that our line goes through, but we're going to have to figure out the slope. What do we know about the slope? Well, we know that our line is perpendicular to another line. Maybe we should just give this a quick graph. Maybe we'll see what we're talking about. We see that the y-intercept's at plus 1, and it's got a negative slope of minus 2, so this thing's doing something like this. It's maybe a bit steep, but it's the right idea. We do know as well that this thing is going through negative 4, 1. We'll say that that's around here, negative 4, 1. And ours is perpendicular, so we know it's meeting at a 90-degree angle. And we want to know what is the equation of our line, which goes through this one and has a slope perpendicular to this slope. Now the slope of the other line is given right in the equation. It's right here as negative 2. Right? Y equals mx plus b, so m of that other line is negative 2. Now, we know that this slope is perpendicular to our slope, and we know that perpendicular slopes are negative reciprocals of each other. So we know that the slope of our line must be the negative reciprocal of negative 2, which is 1 over 2. So that's our slope. So we can sub that right away into y equals mx plus b. Well, y then equals 1/2 x plus b. And then we need to sub in another point that we know is on our line. Luckily, that's given to us right here. Sub in negative 4, 1. We will put negative 4 in the x position and 1 in the y position. So 1 equals 1/2 times negative 4 plus b leaves b by itself. We know that 1/2 times negative 4 will work out to negative 2. And that would mean that b, if we add 2 to both sides, must equal 3. And again, we just take a quick look at our drawing and we say, well, does that look like 3? Yep, I think it does. And we finish with just collecting everything together into our equation, which is that y equals 1/2 x plus 3.